Hi guys, I'm so sorry I'm not there today. I know you were expecting a candy lab today. We will do the candy lab when I'm back tomorrow. I promise. We will do the candy lab when I'm back tomorrow. Okay? So the first thing I want you to do is I want you to check your homework answers. I know almost all of you had it done yesterday. Check your answers, see how you did. I'm going to work through the problem so that if you got any one of the four of them incorrect, you can fast forward this video to that point so you can watch how I did the one that you got incorrect. If you got all the homework correct, then you're going to pause the video. You're going to go do your do now, which is on page 39 of your packet. Then you're going to fast forward the video to page 2 where I go over that problem. Check your answers. Watch the video if you need the help. Okay? All right, here we go. So the first thing you have to do on the homework is you need to find the totals. So if we add up all the people who went to the track meet, that's 60. All the people at the football game, that's 87. All the people at the band concert, that's 66. Now if we add up all the peanuts sold, that's 48. If we add up all the hot dogs, that's 92. If we add up all the Cracker Jacks going across, we get 28. And all the hot pretzels would be 45. Now, if I add up this column or I add up this row, both of them should add up to 213 total. Okay? So now we want to know the probability that it's sold at the track meet given its hot pretzels. So the hot pretzels is what's given. So we know we are in this hot pretzels row, which gives us a total of 45. So our denominator is 45. Then what's the probability they were sold at the track meet? Track meet would be 11. So 11 out of 45, that does not reduce. So that is our answer. Now we want the probability that it's sold at the band concert given they were peanuts. So the first thing we know is we are locked into peanuts. That means there's only 48 possibilities. So our denominator is 48. Now what's the probability they were sold at the band concert? There's the band concert. 3 out of the 48, which when you put in your calculator reduces to 1 over 16. There we go. Now the third one, the probability of hot dogs given they were sold at the football game. So now we know we're locked into the football game, which had a total of 87, so that is our denominator. Now what's the probability that they were hot dogs? Well, 51 of them were hot dogs. So 51 out of 87, and that does simplify to 17 over 29. And there we are. Good. One last one. That would be the probability that they were Cracker Jacks given they were sold at the band concert. So knowing we're locked into the band concert, that has a possible total of 66. Okay. And the Cracker Jacks, there were 20 in that column. So 20 over 66, I'm just going to darken that so you can see it a little better. 20 over 66, and that does simplify to 10 over 33. So there you go. Hopefully, that answers any questions that you had on the homework. Next up is your do now. So if you haven't already done it, pause the video, do your do now problem, and then come back and check. Okay, so we're using this two-way table on wearing yellow or not wearing yellow, blue eyes or not blue eyes. So the first probability we're looking at is the probability that we do not have blue eyes, given that we're wearing yellow. So knowing that we're wearing yellow, that means we only have 40 people total to look at. And if they're not blue eyes, that's 30 out of the 40 people, which reduces to 3/4. The next one says the probability that they're not wearing yellow, given they have blue eyes. So first we lock into the fact that they have blue eyes, which gives us only 12 people to consider. Of those 12, not wearing yellow would be 2 out of the 12 people. That simplifies to 1/6. Okay, next up, we want the probability of blue eyes given that they are wearing yellow. So if they are wearing yellow, we're back in this first column again, okay, which only had 40 people. And of those 40, how many had blue eyes? 10 had blue eyes. And 10 over 40 simplifies to 1/4. Last one on this do now problem. What is the probability that they're not wearing yellow, given that they do not have blue eyes? So not blue eyes is this second row, which limits us to 50 people. So that's our denominator. And of those 50, how many are not wearing yellow? That would be 20. And 20 over 50 simplifies to 2/5. There we go. There's your do now. Okay, now we're going to turn to page 40 in our packet. And we're going to discuss something called Venn diagrams. So the first thing we want to talk about is completing the Venn diagram with the names of described characters. So we need some Disney cartoon characters and we need some cartoon dogs. The first cartoon dog I always think of would be Scooby-Doo. And of course, you can't forget Snoopy, right? And what are some Disney cartoon characters? How about Mickey Mouse? He's the classic, right? Mickey Mouse. Then you've got maybe Simba from Lion King. You've got Donald Duck. Well, how about Goofy? Goofy's a Disney character, but he's also a cartoon dog. So Goofy goes in this intersection. You know who else goes in there? Pluto. Goofy and Pluto go in the intersection because Goofy and Pluto are both Disney characters as well as cartoon dogs. Now, SpongeBob is neither a Disney character nor a cartoon dog, so he is outside of both of those circles, okay? And that's how Venn diagrams work. So let's look at a problem here, okay? So we're going to consider the set of all integers from 1 to 10. In other words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to be our sample space, which they call S. Now notice in the picture, here's S. Everything inside that rectangle is set S, okay? We're going to let A be the set of all integers in S that are prime. So A is all our prime numbers, okay? And B is going to be all our multiples of 3. Now let's look at that set of numbers. Which numbers are prime? Remember, prime numbers are numbers that can be divisible by two numbers, 1 and itself. So 1 is not prime because it's only divisible by 1. 2 is prime, 3 is prime, 5 is prime, 7 is prime. Those are the only prime numbers in that set, okay? Now also, multiples of 3. What numbers do 3 divide into evenly? Or what numbers, another way to think about it, you can multiply 3 by something to get this number. In other words, 3 times 1 is 3. 3 times 2 is 6, and 3 times 3 is 9. So 3, 6, and 9 are all multiples of 3. Now notice this 3 is both a prime number and a multiple of 3. That's going to put it in the intersection here. So that's going to put it in the intersection. Now our prime numbers, our other prime numbers, would be 2, 5, and 7. They go in circle A, but not in the intersection. Now our other multiples of 3 were 6 and 9. So they go in circle B, but not in the intersection. And then we have these other numbers, 1, 4, 8, and 10, that aren't in either circle, but they have to be somewhere inside of the rectangle because they're part of the set. Now we can find certain probabilities. What is the probability that a number we choose is in set A? Well, if we look inside this circle, which represents all the prime numbers, there's 1, 2, 3, 4 numbers in there out of the 10 numbers that we have all together, and 4 out of 10 reduces to 2/5. There's our probability. Now we want the probability of B, meaning the probability that we have a multiple of 3. Well, that would be all the numbers that wound up inside this circle for B. 1, 2, 3 numbers. 3 out of the 10 numbers. That doesn't simplify. Now, why is the following equation not true? Why does the probability of A plus the probability of B not equal the probability of picking a number out of the set, which would be 1? Why does 4/10 plus 3/10 not equal 10/10 or 1? Well, there's a couple of reasons. The first reason is there are numbers that aren't in A or B, right? 1, 4, 8, and 10. Okay, S has numbers or elements outside of A and B. And also, this 3 was in both, so we would not be allowed to count it twice. So also, there is a common number in both A and B. And that's why we can't just add the two probabilities together. Let's try another problem. So here's one where we're going to consider the spinner shown below that has been divided into 8 equally sized sectors of a circle. The spinner is spun once. In this experiment, we will let A be the event of landing on an even number. So if A is the event of landing on an even number, what are the even numbers here? 2, 4, 6, and 8. Then B is the event of it landing on a prime number. What are our prime numbers? Not 1, but 2, 3, not 4, 5, yes, not 6, 7, yes, but not 8. Okay, now we're going to fill in the Venn diagram below with the actual numbers. Now, the first thing I'm going to do is I'm going to look, were there any numbers that were in both? Yes, I've got a 2 with both a blue and a pink. So that's going to go in our intersection of the two circles. Then, okay, set A was all of our even numbers. That was 2 we already have. I'm going to cross that out so I don't forget. We have 4, we have 6, and we have 8. Okay, then if we look at our prime numbers, we still have 3, we have 5, and we have 7. Those are our prime. Now, are there any numbers we missed? Yes, we missed 1, so we're going to put 1 somewhere in the rectangle, but outside both circles. Okay, so now we want to find the probability of A or B. That's the union, okay? Sometimes you'll see that written as A union B with the probability. So the probability of A union B, remember, or means it can be in one set or the other or both. So in other words, when we do this one, we're going to take 1, 2, 3, 4, 5, 6, 7 possibilities out of all the 8 numbers. Very good. And now we're going to look at the intersection. So now it has to be in both A and B. And by the way, if sometimes you'll see the notation for intersection A, it's an upside down U, intersection B. So A and B, the only one that's in both, that's 2. So we only have one number that's in both out of the 8. So the and means it has to be in both, whereas the or means it can be in A, in B, or in both A and B. Okay? All right, hopefully that's helping. Let's try another one. Here we go. So Jess was doing a science fair project by surveying her intermediate algebra class. She found that of the 30 students in the class, okay, so there's 30 students all together, 15 had brown hair and 17 had blue eyes and 6 had neither brown hair nor blue eyes. Determine the number of students who had brown hair and blue eyes. Okay. So let's see. First thing I'm going to do is I'm going to take 6 had neither brown hair. Now notice we have one circle for brown hair, one circle for blue eyes, right? There are 6 of the 30 kids that don't have brown hair or blue eyes. That means of the 30, when I take away the 6, I have 24 students still left. Okay? I have 24 students still left. Now the next thing I'm going to look at is the fact that I have 15 with brown hair. I also have 17 with blue eyes. So how many students is that? If I add that up, I'm going to get 32. Now that's a problem because I'm only allowed 24 more students. Well, that means some of those kids are counted twice. How do I find out how many were counted twice? I take the 32 brown hair and blue eyes combined, and I subtract the fact that I'm only allowed to have 24, okay? That means there are 8 students in common. So the 8 goes in here. They are the intersection. Now we can figure out how many kids had brown hair. So remember, we have 15 kids with brown hair, but 8 of those 15 also had blue eyes. So we're going to subtract them. And that's going to give us 7. So 7 students only have brown hair. Then we're going to look at the fact that 17 students have blue eyes, but 8 of them also had brown hair. So 17 minus the 8 that was common will give us 9 students that only have blue eyes. Now if we check real fast, okay, 7 plus 8 is 15, plus 9 is 24, plus 6 is 30. Now we have our total students. So now the question is, use the Venn diagram to help, determine the number of students who had brown hair and blue eyes, which we actually figured out a while ago. So there are 8 students, that's our intersection, 8 students who have brown hair and blue eyes. Okay, let's try one more together, unless you think you really have it. So here we go. In the study below, 52 graduating seniors were surveyed as to their post-graduation plans, and then the results were sorted by gender. Let the following letters stand for the following events. M is male, F is female, C is going to college, and N is not going to college. So we have a two-way table, which we've been using for several days now. Not a problem. Let's do some probabilities. If a person was picked at random, find the probability that the person was first a female. So, of all the students we have 52 students. How many of them were female? Oh, there were 22 females. And if we simplify that, we'll get 11 over 26. There we go. What is the probability that the student is going to college? Well, going to college, we have 29 students going to college out of all the 52 students. That does not simplify, so that's our answer. Now we want to find the probability that they're going to college given they are female. Now there's a couple of ways we can do this, and we're going to do it the way we did it first in the past. So the probability they're going to college given they're female. So we know that they are female. That means we have a total of 22 students that we can look at because there's only 22 females. Now of those, 13 of them are going to college. So here is our probability. Now they want us to put this into the Venn diagram. Now here's the thing. We know that there are 22 females altogether, right? We know that 9 of them are female and not going to college, and 13 of them are female and going to college, right? We also know how many are going to college that are not female. That's 16. Okay, that's 16. Now, we can also say, okay, let's see, 9 plus 13 plus 16, that's 9, 18, that's 38. We had 52 students altogether, so if we subtract them, there are 14 students that are not female and not going to college, okay? So we can also do these probabilities from the Venn diagram, but I think most of you will have an easier time if you stick with the way we've already been doing it on the tables, but it's up to you which way you want to do it, okay? Let's look at the next probability. Which is more likely that a person picked at random will be going to college given that they are male, okay? So that would be this one here, going to college given they're male. So if we're given that they're male, that gives us 30 students altogether, and of those, 16 are going to college. That reduces to 8 over 15. Then we have the probability that the person will be male given that we already know they're going to college. So if we limit ourselves to going to college, that's 29 students, and of them, 16 are male. So that's 16 over 29. Now, it's hard to compare these two fractions because their denominators are very different. So what I want you to do is in your calculator, if you do 8 divided by 15, now don't just hit enter, hit second enter. It'll give you the decimal, and that decimal should come out to 0.533. So it's about a 53.3% chance that the person will be going to college given that they're male. Let's do the same thing for the other probability. We're going to do 16 divided by 29, then do second enter so that it gives you a decimal. The other thing you can do is 16 divided by 29 and then hit a decimal point before you hit the enter, and it'll do the same thing for you. I don't know if you knew that. When you do that, you should get a 0.5517 something, something, something. So that's about a 55.17% chance. This is the better probability, so this is more likely that the person will be male, given that we know they're already going to college. All right, guys, so what I want you to do next is I want you to turn to page 43. I want you to try questions 5 and 6. If you have trouble, especially 6 because it actually uses 3 circles, that's okay. If you have trouble, just keep going with the video and we can do the 2 problems together. Don't worry about it. I will take questions on Friday. We're going to do more with Venn diagrams on Friday also. Okay, so no panicking. Let's see what you can do. All right, so if you want to pause the video, go try them. Maybe try number 5, then come back, watch the video, make sure you got it right. Then try number 6, come back and watch the video. Okay, guys, here we go. All right, if you tried this already, your answer should be 451 over 480. If you got that, great. If not, let's see how this worked. So Farmingdale High School has 480 freshmen. Of those freshmen, 333 take algebra, 306 take biology, and 188 take both algebra and biology. Create a Venn diagram of the following situation. So the first thing is we need one of these circles is going to be for algebra. One of these circles is going to be for biology. And the whole thing is for the freshmen. Okay, so what should we do first? Now, I'm going to start with what the kids who take both, this 188, I know they go in this intersection, right? And that also means that if I know that 333 kids take algebra and I subtract the 188 of them, what do we get when we subtract that? We get 145. That means 145 freshmen take algebra but not biology. Then I can say, okay, who takes biology? Well, there are 306 students taking biology, but 188 of them also take algebra. If I subtract that, that's 118. So 118 students take biology, but not algebra. Next up, I want to take the totals here. I want to add what's in those 2 circles. We've got the 145 that take only algebra. We've got the 188 that take both algebra and biology. We've got the 118 that take biology only. And we're going to add up those 3 numbers. If we add them up, we get 451. There's a catch. There were 480 freshmen. So I'm going to take that 480 freshmen, I'm going to subtract that 451 that take algebra or biology, and that leaves me with 29 that take neither algebra nor biology. So 29 students are outside both circles but inside the rectangle. Now, we haven't answered the question yet. The question was, what is the probability that a freshman is taking at least one of those classes? That means one or more of those classes. That means algebra or biology or both. Well, didn't we just do that total over here? Woo! 451 out of how many students altogether? 480, and this is our probability. There you go, guys. All right. Okay, so number 6. There are 24 dogs in a kennel. 24 dogs in a kennel. I can't write my 4. 24 dogs. Okay. 12 of the dogs are black. 6 of the dogs have short tails. And 15 of the dogs have long hair. Oh, but there is only one dog that is black with a short tail and long hair. So there's only one that fits all 3 categories. So you know what? Let's do this. We're going to have the black dogs. We're going to have the short-tailed dogs. And we're going to have the long-hair dogs in that circle, okay? And what did we just say? There's only one dog that's in all 3 categories. But, you know what? Having all these numbers is going to drive me crazy. I have a total of 24. I need to have them in numbers instead of words. We have black dogs. There are 12. We have short tail. That's 6. And we have long hair. That's 15. See, I'm going to go back and forth. It's going to drive me crazy. Okay, so now, where were we in this paragraph? 2 of the dogs are black with short tails, but do not have long hair. So they are black and short tails, but no long hair. So black and short tails, that's in here. So there's 2 in there, right? Then we have 2 of the dogs have short tails and long hair. So short tails and long hair, those intersect here. All right, if all of the dogs in the kennel have at least one of the mentioned characteristics, that means they're all inside the circles. None of them are in the rectangle outside of the circles, okay? How many dogs are black with long hair but do not have short tails? So what is it we're looking for? We want black with long hair but do not have short tails. So black and long hair but not short tails. We want to know how many dogs fit in this category, okay, that intersect in those 2 circles. So let's see what we do know. Let's just look for a minute at the short-tailed dogs. Let's look at the short tail, okay? We already know we have 2, 1, and 2. So if I do 2 plus 1 plus 2, that's 6. Whoops, I can add. 2 plus 2 is 4, plus 1 is 5. But we only have a total of 6. So 6 minus 5, there's only one dog that has only a short tail. Okay, so he's there all by himself. Now, let's take a look at... So how many dogs do we have already here? So we now have 2, 4. We have 6 dogs accounted for, right? So we have 6 dogs accounted for, and we had a total of 24. So 24 minus 6, we still have 18 dogs to go, right? Now let's look. For the black dogs, what do we know? I've already got 2 and 1. I have 2 plus 1 is 3, right? And a total of 12. So 12 minus the 3 means I have 9 dogs left. But that 9 isn't all going to go in here because some of them are going here. Let's take a look at the long hair. What do we know about the long hair so far? Well, we know we've got 1 and 2 here. so we also have 3. But we only have a total of 15 minus 3, so we have 12 of these, right? Now, if we were to add these together, that would be 21, true? And we already said a while ago over here that we have this 5 plus 1, we have 6 already. So if I take that 21 plus the 6, that gives me 27 dogs. But there's only 24 total. So if I subtract 24, that means there's 3 dogs in common that go here. That's our answer. And not only that, if I do 9 minus 3, I'm going to have 6 that are black only. And if I do the 12 minus 3, I'm going to have 9 that are long hair only. All right, guys, there we go. I hope this helps. Have a great day.